Okay, so today we are going to talk about relations and functions. Open your notebook to page 26 and go ahead and label it 3.2, Understanding Relations and Functions. And go ahead and label 27 the same thing. We're doing 26 and 27 today. Remember, if you're at home, don't have a printer, doesn't matter. You just need to be writing in your notebook. Okay, so if you do have a printer or you're at home because, well, hybrid's over, so not hybrid, but any other reason, take your foldable, fold it into the center, and into the center. I'm going to grab the scissors I forgot. And I'm going to cut so that I have 4 flaps. Okay, and then we're going to talk about the different ways that you can have a relation. Okay, I'm going to kind of put my notebook to the side for now and just write on this foldable. So first of all, there is a way to have a relation, and that is a set of ordered pairs. Okay, so in a set of ordered pairs, and when you say where are you getting these, I'm just going to be making them up. Okay, but a set of ordered pairs are always written inside curly brackets. These are these little things right here are curly brackets. Okay. Each ordered pair is separated from the next with a comma. Okay. So we're just going to write down some points, and yes, I'm making these up. Let's say the first one is 3, 2. Next is 5, -1. -4, 3. 2, 0. -3, -1. And 2, 5. We're going to use these for the entire foldable. So one way to show a relation is just by a set of ordered points. Okay, this, as we learned yesterday, is a discrete set of points here, a discrete relation. All right. Next, we have an input-output table. Tables. In tables, the input is always x, and the output is always y. So in a vertical table, you have x and y. In a horizontal table, you have x and y. Okay, we're going to fill this table out with the points we just created. Okay, we do normally like to put them in order. When I say in order, what I mean is we take the smallest x value and put it first. The smallest x value is -4, 3. So the y's won't be in the order, the x is the ones in order. Okay, -3, -1. 2 looks like it's next, but let's put 2, 0 first, then 2, 5, then 3, 2, and then 5, -1. So we ordered it by the x values. If we had the same x value, we did it by the y, okay? The x, then the y. All right, we're going to fill in the exact same thing here. -4, 3, -3, -1, 2, 0, 2, 5, 3, 2, 5, -1. So either way it's written, we order them by the x's, okay? So you have a set of ordered pairs, you have an input-output table. We can also have a coordinate plane. The coordinate plane is just graphing it. The x-coordinate tells you how far to move left or right. The y-coordinate tells you how far to move up or down, okay? So I'm just going to be graphing. I'm going to graph in the order they are up here, 3, 2. So over 1, 2, 3, and up 2, there is 3, 2. 5, negative 1. 1, 2, 3, 4, 5, down 1. There's 5, negative 1. Negative 4, negative 1, negative 2, negative 3, negative 4, 3. 1, 2, 3. 2, 0. 1, 2, and I don't move up or down. Negative 3, negative 1, negative 2, negative 3, negative 1. And 2, 5. Over 2, up 1, 2, 3, 4, 5. There's my coordinate plane. That should be a review. You should already know how to graph points. Okay. Last but not least, we're going to open up and talk about a mapping diagram. So there are 4 different ways to show a relation. Coordinate points, ordered pairs, input-output table, coordinate plane, and now we've got a mapping diagram. The left shape contains all the inputs, which are the x values. We can write x right here if we need to. The right shape consists of all y values, the outputs, without repeats. You do not repeat a number. If it is in there one time, I only need to put it in, if it shows twice in the points, I only have to put it one time. Then an arrow is drawn from each input value to its corresponding output value. So I'm still using the same points, but I'm going to kind of zoom in. I'm going to look at the ones at the table just because you can see those on the screen. Okay, I'm going to put in these x values. Negative 4, negative 3, 2. Notice I have 2 2's. I'm only going to put 1. I don't put repeats. 3 and 5. I'm going to put the y values in. I also am not going to repeat. I'm going to order the y values as well. Negative 1 is going to go first because it's the smallest number. There are 2 of them, but I'm not going to put 2. 0, then 2, then 3, then 5. There are all my input and outputs listed. Now, the next sentence says an arrow is drawn from each input value to its corresponding output value. I'm going to zoom out just a little bit so we can see these points. Negative 4 goes to 3. That means I'm going to draw an arrow from negative 4 to 3. And I want it to look nice, precise, and even, so I'm going to use a straight edge. Negative 4 to 3. Now, negative 3 goes to negative 1. Two goes to 0. Okay. 2 goes to 5. So 2 goes to more than one thing. It's just like matching. Remember matching back in elementary school? 3 goes to 2. And 5 goes to negative 1. Negative 1's got 2 things going to it. Okay. There we go. There's a mapping diagram. So we have all 4. In today's homework, you will have to show all 4. Okay. This, if you have a printer and have printed it off, or if you have this paper, you are gluing it to 26. If not, you wrote all this on 26. Okay. So if you have this, you're gluing it to 26. You will have to create all of these, not only on homework, but eventually on a quiz or a test as well. Okay, now we're going to be working on page 27. So you're either writing on page 27 or you've got what I'm fixing to show you. Keep in mind, we've talked about 4 types of relations, the ways to represent relations. Ordered pairs, input-output table, coordinate plane, mapping diagram. We will come back to each. All right, there's a paper, looks like this, folded in half. We're going to talk about the difference between a relation and a function. Okay. A set of pairs of input and output values is a relation. An example of that is on page 26. Yeah. I'm not going to show you an example of a relation. We just did that. It's on page 26. A relation where every input has exactly one output is a function. So a function is a type of relation. Okay? I'm going to draw a table. Let's talk about what that means. Okay? I'm going to use the same coordinates I had over here. And I'm going to look at the table. I had -4 and 3, and I had -3 and -1, and I had 2 and 0. Remember, these are the inputs, these are the outputs, so every input can only have exactly one thing over here, which means, you see how in the notes from a few minutes ago that x had 2 twice? That's not a function, which means I'm not going to put 2, 0. I'm going to leave that one out, and I'm going to stop right here. I don't have to keep filling it out. This is a function because every single one of these is only written once. It only goes to one thing, okay? That is a function. Let's open up and have some examples of what is a function and what is not a function. Just so that you know, let's write this out here too. In a function, x's do not repeat. Y's can repeat, but x's do not repeat. Okay? There is also something called a vertical line test. In a vertical line test, you know whether something is or isn't a function based on, if you take a vertical line, straight edge or something, if you touch more than one point at a time, it's not a function. See how I touched more than one point? It's not a function. Now, if this was moved somewhere, let's say it was over here, I wouldn't touch more than one point at a time. So this would be a function, okay? That is how you determine whether something is a function or isn't a function if it's a graph. All right, so let's open this up, talk about what is a function and what's not. So in the first one here, this is a function or it is not a function, and why? We have a graph. Graph means we need to look at the vertical lines. I only have these 3 points, and look, I touch all 3 of them at the same time. This is not a function because it does not pass the vertical line test. Okay. The next one. Is this a function or not? Does every input go to exactly one output? -1 goes to one place. Good. 2 goes to one place. Good. 3 goes to one place. Good. 5 goes to one place. This is a function. It would not be a function if 3 had 2 arrows coming off of it. This is a function because every input has one output. Exactly one. So just writing the definition there. All right, and third, we have to decide, is this a function or not, and why? So look at our x's. Do we have any repeaters? Oh, we do. This is not a function because the x's repeat. Not a function because the x's repeat. All right, let's do a couple more examples. Some of this is a review from yesterday. All right, this says, give the domain and range of each relation and interpret them in context. State the corresponding outputs for the given inputs in context, and explain whether the relation is a function. By the way, all 3 of these go with the same thing. So let's first of all It says first to give the domain and range. So we're going to do domain and range. Then it says interpret in context. We'll talk about what that means. And then it says determine whether it is a function. Well, let's go ahead and look at that. Does 2 go to one thing? Yes. Does 3? Yes. Does 4? Yes. Does 5? Yes. This is a function. All right. Yesterday, though, we talked about domain and range, and I'm actually going to skip a line. You're going to see why. I should have done that before. Okay, so domain and range. Domain is the x values. Range is the y values. I can take the x values from here, or from the graph because they're all the same, okay? I'm going to look at them from here just because it's closest to me. So the domain, remember, curly bracket, is 2, 3, 4, 5. And range, 4, 6, 7, 9. Remember, in a discrete function, which is what this is, a discrete graph, right here, you put curly brackets in the actual points. Now, if it was a graph that kept going forever, you would put a range of, like a compound inequality or something. All right, the only part we haven't done, it says state the corresponding inputs and outputs in context. So we're going to see what this means. The domain means books sold. The range means the price. That's what it means by put it in context. You need to understand which is which, okay? All right, I want you guys to try 6 and 7. So I'm going to zoom out so you can see it. You're deciding, is it a function or is it not a function? I want you to do 6 and 7. Pause the video, try them, and I'm going to go ahead and get started. So it says, use the vertical line test to determine if each relation is a function. I can't speak. Okay, so I've got my vertical line here. I'm just going to pass it over. If I touch more than one point, the answer is no. I did not. This is a function because I never touched 2 points or more at the same time. Let's look at 7. Vertical line. Oh, here's my vertical line. I touch 1, 2 points at the same time. This is not a function. Today's assignment, you will be determining if things are a function or not. You will be creating tables, graphs, mapping diagrams, and filling out domain and range, okay? This is going to be going on page 27. If you wrote on 27, that's what you were supposed to do. So fold this, glue it in on 27. Go ahead and get started on the assignment, and I will see you tomorrow.